So next we do the exercise example of the actual question. So consider this is a voltage divider configuration circuit. This is a common source. Okay, so this is common source because the input of the amplifier is at the gate and the output is at drain. The source is not used, so this is a common source. And the bias circuit is a voltage divider configuration. Okay, and this exercise, first you need to do the you need to find Vgsq and Idq. So the first part is this is a DC analysis. This is DC analysis. Okay. So let's find the IDQ and Vgsq. So to find it, for the DC analysis, you need to remove the capacitor. Open circuit, you remove the capacitor, and then this part can be ignored. So you only consider the voltage divider circuit only. Only this voltage divider circuit. Okay, and then this is a voltage divider. So you need to do the theorem, Thevenin theorem, Thevenin transformation. So you need to calculate what is R1 parallel with R2. This is the R Thevenin. R1 parallel with R2. Okay. So however, for the MOSFET, the value for R1 parallel with R2 is not that important when you want to do the DC analysis, because this will not affect the calculation. Okay. So and then for VTH is 2.2 mega over 2.2 mega plus 4.7 mega times 18. So this is equal to 5.74. So the circuit can be redrawn as something like this. This is RTH. This is 2.2K. Okay. So now you have transformed this equation. So the next step is you define what is the transfer equation. The transfer equation is ID over K Vgs minus Vgs square. So the K is given. Is it the K is given? So the K is given as 0.5 milli, and the threshold voltage is 2 volt. Okay, so this is 0.5 milli. This is Vgs minus 2 square. So this is equation number 1. Equation number 2 is the KVL from the input loop. So the KVL is minus 5.74 plus the voltage drop at the RTH. This is the current is IG RTH. However, this is equal to 0 because the gate current is always 0. So we have this one is plus, and then we have the VGS. Between the gate and the source, we have the voltage drop VGS. Then the last term is ID 500 ohm equal to 0. So you got here, this is minus 5.74 plus VGS plus ID 0.5K equal to 0. This is the second equation from the KVL. Next step is you solve the first and the second equation. So now let's do the mathematical equation. From this equation number 2, you can define the ID as equal to 5.74 minus Vgs over 0.5k. Okay, from equation number 1, ID is equal to, this is also equal to 0.5 milli Vgs minus 2 square. So solve this equation, you get this one is 0.25 Vgs square minus 4.74 equal to 0. So you get this one is Vgs has two solutions, which is 4.36 or minus 4.36 volt. So the valid solution will be the value which is bigger than the threshold voltage. Threshold voltage is 2 volt, so the valid value is, this is 4.36. Once you get the value of 4.36, the IDQ can be calculated using 5.74 minus 4.36 over 0.5k, you will get 2.76 milliampere. So this is the solution for IDQ and Vgsq. Okay. So the next question is you need to draw the mid-band AC equivalent circuit. Okay, this is a voltage divider. Okay, let's draw the AC equivalent circuit. So we start from the voltage source here, and then we have the coupling input, short circuit. R1 and R2 is R1 is connected to the ground as well as R2. So at this point, I can also rewrite this resistor as the R1 parallel with R2. Okay, and then next we have this one is the gate. So the gate source is open circuit. This is your VGS, and then at the source, since we have this bypass capacitor, RS will not appear, so the source is directly grounded. And then we have between the source and drain, we have the current source. This is your GM VGS. Okay, and then in this question, the RD is infinity, so this is open circuit, no need to draw the RD. Okay, at the drain we have this RD and we have this RL. Okay, so this is your AC equivalent circuit. Okay, from this AC equivalent circuit, you can calculate what is input impedance. Input impedance is seen from this input port. So you see from the input port is R1 parallel with R2. So if you calculate the R1 and parallel with R2, you can write down the answer. So this is 4.7 mega parallel with 2.2 mega. So this is equal to 1.5 mega. For the output impedance, it is seen from this output port. This is the Z out. The Z out is equal to RD, which is equal to 2.2 kilo. Okay. For the voltage gain, AV is equal to V out over the V in. So the V out is equal to minus GM VGS RD parallel with RL. Okay. Actually, I forgot to calculate the GM. So what is GM? GM is GM is 2 times square root K IDQ. So this 2, the K is 0.5 milli, and IDQ is 2.67 milli. So this will give the transconductance of 2.35 millisiemens. The unit for the transconductance is Siemens. So this is we give you the V out is minus 2.35 milli. VGS RD is 2.2K. RL is 1K. So this is will give you minus 1.62 VGS. This is V out. And then for the VI is equal to the VGS. So the AV is equal to minus 1.62 VGS over the VGS. So this is minus 1.62. So this is the answer for the voltage gain.